Today, we have an essential question that we've been working on, and we have some new core math ideas that we're talking about today. Do I have a volunteer to read the essential question? I know I'm right in the way. Caesar.
How can I interpret functions in the various forms to give meaning of the relationship between variables?
So we're looking at, again, functions and how those variables relate to each other. Do I have a volunteer to read the first core math idea? Venetia.
I can compare functions by analyzing their verbal descriptions, equations, scales, and graphs.
Thank you. And the second core math idea. Do I volunteer to read that one? Caesar, go for it again.
I can compare the rates of change for different functions.
So we're looking at functions. We've talked about functions. You're over by John. Here you go. We've talked about functions. We've talked about the equations that go with them. We've talked about the tables. We've talked about the graphs. We've talked about them using words. Now we're going to compare them, looking at this function compared to this function. Okay? Then we're going to look at their rates of change, which you've already done. What's another word for rate of change? The unit rate sometimes is our rate of change, often. What else?
Slope.
Say it one more time, Emily.
Slope.
Slope. So the first thing we're going to do is start with some private reasoning time. Now I made this copy so that it's a side-by-side copy, so that you're not having to flip back and forth the whole time. So when you get this, please put your name on both pages so that I know whose is whose. Okay, can I get your help, John Maleth, please?
Yes, ma'am.
3, 4. Caesar.
Okay, Mama.
Oh, come on. How many are there? 4. Extra?
I bet you this thing in my resume.
So I should see you writing your name on both pages, please. Where do you write that? Name on both pages, please. I know there's not a spot on the second page, but thank you for doing that. Thank you, John Maleth. Did I get one for you? Okay. Caesar, will you please leave that alone? Okay. Thank you for your eyes, Martha. Thank you for your eyes, Jenny. Can I please have you pivot if you need to pivot and face me, please? Thank you, Miguel. I'm looking for this group over here. Thank you. Okay. You have 2 functions. You have 2 functions with 4 representations for each function. Function A is on the left. Function B is on the right. And you have a verbal description for each. You have an equation for each, a table for each, and a graph for each. Okay? So everything is complete here. So unlike the warm-up, you don't have to graph it. You don't have to finish the table. I already did that for you. You've shown that you know how to do that. We practiced it on the warm-up. What you need to practice today is how do we have what are our similarities and differences here? So if you look at that second page that I handed out, please. We're going to begin with 4 minutes of private reasoning time. 1 minute per explanation. Emily, will you please read number 1, what you're supposed to do?
Explain one way that the verbal descriptions are similar or different.
So if you look at the verbal descriptions for function A and function B, explain one way either they are similar or different. Do you have to explain one of each?
No.
No. Just either how are they similar or how are they different. Please use a complete sentence. Zach, will you please read number 2? Can you say that a little bit louder, please?
Explain one way the equations are similar or different.
So what's different between 2 and 1? What are you explaining on number 2?
One way the equation is similar.
So instead of talking about the verbal descriptions, Dakota, you're talking about what's different? What does it say? The equation. Thank you, Venetia. And then number 3. How does that question change on number 3?
You're explaining the tables.
Looking at the tables. Number 4. How does that question change? It's looking at the graphs. So for number 1, you're comparing the verbal descriptions. For number 2, you're comparing the tables. And for number 3, for number 2, you're comparing the equations. 3, the tables. 4, the graphs. Questions? You have 4 minutes of private reasoning time. I need to see at least 4 sentences written down. You do not have to complete number 5 yet. Okay? Those first 4 sentences, you have 4 minutes. Privately reasoning, please. Did you get the first page? Okay, finish getting your current thought down on paper. Nice, Kyle. Good job. Good. Swooping or something. Okay, and if you would give me your eyes up here in 3. Thank you, Zach. 2. Thank you, Venetia's group. 1. Thank you, Olive's group. 0. Thank you, groups. Okay, we are going to use this for our student structured math talk. So we've got our sentence stems here, and you are going to talk to your shoulder partner. Okay? So your shoulder partner is the person sitting next to you. Good, except for Gladys and Jose, you guys will talk across. Okay? The person sitting next to you, and we have our group of 3 over here. Okay? The first thing one of you is going to say is, one way the verbal descriptions are either similar or different. You don't have to, remember, you only have to pick one. One way the verbal descriptions are similar or different is. So when Courtney's talking to Josh, she's going to say, one way the verbal descriptions are similar, and she's going to explain what she wrote. And then Josh will say, one way the verbal descriptions are, he chose a different, so they have a similarity and a difference. Okay? Then they're going to go to the equation one. One way the equations are similar or different is. And then to the table one, and then to the graph one. Make sure that both partners get an opportunity to speak. What are your questions? Okay, I'm coming around because I want to hear what you have to say. Go ahead and start. Pick the partner with the longest hair to go first.
The weave is hella long. One way the verbal descriptions are different is because they're talking about different things. Like one is talking about babysitting and another is talking about miles.
So you just finished. So now he needs to go, right?
But they're similar because they're different because they're using one by babysitting.
Wait. Stop talking. You have to do what way the verbal descriptions are.
Oh shit. It's similar.
No. What are you doing?
Descriptions are different.
One way the verbal descriptions are different.
And you have to substitute for it.
Because
Oh my god.
Okay, thank you for finishing your conversations. I'm going to do a slow 10 because there's still a couple conversations finishing. 9, 8, or not. 7, 6, 5, 4, it's okay. 3, 2, you good? 1, and 0. Okay, so we've talked about how they're similar and different. That's part of our core math ideas. Comparing the functions, analyzing their verbal descriptions. Did we do that? Did you analyze the verbal description? Did you analyze the equation? Did you analyze the table? Did you analyze the graph?
No.
So you've analyzed all of those pieces. So now what's the next core math idea we have to tackle? Say that again? Comparing the rate of change. Let's see. Martha, will you please read number 5?
How do you know based on variables?
Will you start up above the table, please?
Which function has a greater rate of change?
So which function has the greater rate of change? Most of you probably already looking at this have an idea. What we want to know is how do you know from each of the 4 representations? Okay? So how do you know from the verbal description? That's part A. How do you know from the equation? So part A, how do you know from the verbal description? So you're comparing these two. How do you know which one has the greater rate of change? Explain that. And then you're also going to do how you know from the equation. And then you're going to talk about how you know from the table and how you know from the graph. That's what each of those cells in that table are for. Question on the directions. Right now, I want to give you 1 minute to just answer part A. How do you know from the verbal description which function has the greater rate of change? So just looking at part A, from the verbal description, how do you know which one has the greater rate of change? Okay? So which one has it, and how do you know? Take 1 minute to describe that. Go. Okay, thank you for your patience on part A. I know some of you were moving on, and that's okay. Go ahead and give me your eyes up here for your sentence starter. With your partner. The brown sentence. Function, you'll choose which one, has a greater rate of change. I know this based on the verbal descriptions because. So you're going to start with the brown sentence to tell your partner if you think it's A or B, and then how you know based just on the verbal descriptions. Based just on the verbal description. Questions? So you should only need about 30 seconds per partner because you're just going to read what you wrote. Okay, so partners, this time reverse. So if you have the shorter hair, you're going first.
Function B has a
I know, I'm so mean.
rate of change, and it is based on the rate of verbal description because it's bigger than A.
Okay. Function B. Function B has a greater rate of change because the numbers are higher
Oh my
than.
God. It's bigger.
Okay, numbers. I said higher. Do you know how to rate
Yes.
the one function A? What did you say?
She said B was bigger.
Okay, go ahead and finish your conversation in 3,
Is that your music playing?
2,
No.
1, and 0. Okay, so the next thing you're going to do is what? What do you think you're going to do next? Use your prediction skills. Part B, part C, part D. So 3 more parts, 3 more minutes. Go. Private reasoning. My bad, sorry. Private reasoning time, please.
I do know this thing.
So now you're going to answer for the equations, Kim. Okay? So, let's see. I guess it's long hair's turn to go again, right? Which function has a greater rate of change? Hopefully it's the same function, right? How do you know based on the equations? And then how do you know based on the tables? And then how do you know based on the graphs? I would like both partners to share, please. Even if you didn't get it written down, and you can just point at your paper and say, this is how I know, so that we have those conversations. So go ahead and share with your partners. Go.
I'm trying to finish. Okay. I know the rate of change. Wait, no, we're on this one. Okay. I know this based on the verbal description because the equation. Oh wait, because function B is bigger. Wait, because the number they multiply by is a larger amount than in function A. No, wait, I'm not done. I know this based. Okay, no. I know based on the table it's a function that function B is a greater rate of change. Wait.
Okay, so it sounds like we're ready. Almost. Go ahead and wrap it up.
Did you get our job over there?
That one's like
Okay. Okay. So I would like to highlight some things that I heard some students say on our public records. Okay. So looking over here, first comparing the verbal descriptions. Courtney, what did you notice? Will you please read what you noticed for the functions? So for part A, sorry. Say it one more time so that these gentlemen can hear you back here.
Table B has the greater rate of change because in the description they are going up a lot more faster than table A.
So this one's greater because what's going up faster? Sorry.
The rate of change.
So how do you know that from the verbal description?
Because it has a greater rate. It's like the graph, like in table B is going more faster than in table A.
But what about from the verbal part? How do you see that in there?
Because she's going 45 miles per hour and when the other person is going babysitting for the
So it's greater because 45 miles per hour is greater than $7 per hour? What do you guys think? Anybody else have something like that? No? Yeah? Thank you, Dakota. Anyone else? Caesar? Nice. What about with the equations? How do you know from the equation which function has the greater rate of change? What do you know about that one? Enrique, would you share, please? Which function did you see having the greater rate of change, and how do you know? Yeah, by the equation. So part B.
Okay, so function B has a greater rate of change because there is a equation has a 43 number difference than function C.
So this one's a greater rate of change. Say that one more time. Because why?
Because function B has a 43 difference than function A.
Where's that 43? Explain that a little bit farther to me, please.
Because if you add up 45 and 15, that equals to 60, and if you add 7 into 10 or 17, and if you subtract it, it goes into 43.
So you said 45 plus 15 equals 60. And then you said 7 plus 10 equals 17. And then 60 minus 17 equals 43. Okay? So this 43 is the difference between how many hours? How many hours would that have to be for babysitting versus driving? What would X have to be for that to work? So if I did 45 times 5, I'd get 60? When would I get 60 for this equation?
On the first hour.
So the first hour. So it has that 43 for the first hour. Yes? So just getting a little bit more precise with our vocabulary for the first hour. Thank you, Enrique. So far, it looks like function B's greater rate of change. What about from the table? What about from the table? How do you know from the table? Gladys?
I know this based on sales because function B, the distance from home adds up to 45, while function A adds 7 to the 50.
And so which function? I missed that part.
So function B adds 45 to the distance, and function A adds $7 to the 50.
So it's greater because it increases by 45 miles per hour, while A increases by $7 per hour. And you saw that in the table here? Could we label that in the table here? Where could we label that? How would we find that on the table? How would we show that 45 on this table?
What is subtracted 105 by 60.
So you found this was a 45 change there. Okay, and then over here you found 7 change there. Okay, now the table or the graphs. Emily, will you please tell us why you thought function B had the greater rate of change?
Because function, the line on function B is steeper, and on function A, the line is not as steep.
So you use this word, the line is steeper. Can you go a little bit more into depth on what you mean by the line being steeper? What does it mean for a line to be steep?
It goes like up more, like gets a greater value or something.
So that it's a little, it's kind of hard to describe, isn't it? I'm thinking about the Olympics right now, right? The Olympics are going on, and when you see a ski jump, is it not steep or is it steep?
It's steep.
They're doing a lot of steep stuff, right? So it's that hill that, man, you hope you have skis because if you're going down that any other way, it's dangerous, right? So it's steeper. Zach, will you tell us why you thought function B's graph had the greater rate of change? And actually, will you come up and draw it for me, please? Will you just show me what you drew on your graph, please? I'll show them. I saw it.
Put your pants up.
You guys are going to look at this and you're going to go, oh, yeah, I forgot about that.
Good try.
You drew the triangles, remember? Yeah. And then I heard Olive say it, too. That's okay. You're freehanding it.
I'm on the way.
Olive, what did you say? The triangles, right? You're looking at the change in y over the change in x. Remember that delta y over delta x? It shows us that this ratio here is greater than this ratio here. Okay, so that is another way to look at that. Right now, will you please pile your papers on one person's desk, and you've got an exit ticket.
You're not going to go on top. I always put the people with the better handwriting ones.
Your exit ticket has a choice on it. Nope, that's not the choice, Caesar. Nice try. There are 4 questions. You only have to answer one of them. This will help me know where we need to go tomorrow, or Tuesday.